Imagine teaching two students. One gets both the questions and the answer sheet. The other only gets the questions and has to figure out everything alone. Which one learns differently? That's exactly what's happening in machine learning. Today, we'll break down supervised and unsupervised learning, when to use each, and why this one difference changes everything. Supervised learning is like learning with a teacher. Every example comes with the correct answer, so the model keeps adjusting until its predictions match reality. Unsupervised learning has no teacher at all. It receives only raw data and starts asking, what patterns exist here? Instead of memorizing answers, it uncovers relationships hiding beneath the surface. Their goals completely diverge. A supervised model sees a new input and confidently predicts an answer: spam or not spam, cat or dog, price or no price. And an unsupervised model doesn't predict labels because none exist. Instead, it starts organizing the data into meaningful groups, discovering clusters that humans may not even notice at first glance. Choosing the right approach comes down to one question: do you already know the answers? If yes, use supervised learning for predicting tasks like fraud detection, image recognition, or forecasting. If not, unsupervised learning becomes your explorer. It's perfect for customer segmentation, anomaly detection, or revealing hidden structures buried inside massive datasets. Here's an analogy that sticks. Supervised learning is studying with flashcards. Every card has the answer on the back, so every mistake teaches you something. Unsupervised learning is dumping out a messy drawer of random objects. Nobody tells you how to organize them. You naturally group similar things together. One learns from answers, the other learns from similarities. So here's the key takeaway. Supervised learning predicts what you already know how to ask. Unsupervised learning discovers what you didn't even know to look for. Master this distinction and you have built the foundation for almost every machine learning algorithm you'll encounter next. Thanks for watching and I'll see you in the next one.